Okay, here we go. AP2, this is probably the first video we've done. So everything's good. Hope you're enjoying the snow days. We're ready for Black Day try tomorrow. Last week we stalled. Let's be honest. We stalled, and the questions that you had on AP Classroom were really super detailed about the electromagnetic spectrum and what was going on with it. Make sure you do that assignment. It's not hard. Focus on that. Now, the reason we stalled is because this next step, there's a lot of drawing to, and it really takes some whiteboard time and some explaining time. But here we go. We're going to start with concave mirrors. We're going to keep it real simple. Concave mirrors, P, Q, and F. Okay? P is the object distance. Q is the image distance. F is the focal length. Okay? P, all of them are measured. All the distances are measured along the principal axis from the far, far back of the mirror. So if you've got a concave mirror, it's measured from back here. It's not measured from here or here. It's measured from the deep part of the cup, all the way back where the principal axis hits the center of the sphere. Remember, these are drawn as hemispheres. Technically, they're parabolic. We showed some of that with the graph in class, and how that a parabola gets rid of spherical aberration. In fact, we're going to see a little bit of spherical aberration in the drawings that I've got for you. All right, P is the object distance. How far is the object from the mirror? Q is the image distance. How far the image shows up from the mirror. F is the focal length. In a hemisphere, in a concave or convex mirror, the focal length is half the radius. That's important. Focal length is half of the radius. So I've got some of these mirrors drawn. So if you've got a perfect sphere, cut it in half. Okay, now you got a hemisphere. Here's the center. That's your radius. Well, half of that, that's your focus. That is the distance to the focus from the back of the mirror. Okay. Let's just try it. Here we go. Image number 1. Okay. Image number 1 is going to look like this. That's not going to get any better. There we go. All right. P, you got 8 centimeters. Q, we don't know. F is 2 centimeters. Radius is 4 centimeters. So I drew over here. I drew a 4 centimeter mirror. I used a compass, got a 4 centimeter mirror. And then I put an object 8 centimeters back, measured from here, the center. Don't measure from up here. It's a curved mirror. You're measuring at different distances. Measure from here, went back 8 centimeters, got it. Okay, that's all you need. You've got P, Q, F, R. Okay? Focal length is always half the radius. Everything's good. There are 3 lines. Books do this different ways. There are lots of different methods you can use to solve this. We're going to focus on 3 lines. Parallel focus, focus parallel, center, center. That's it. Symmetry, inverse symmetry. Okay. Lines that come in parallel, by definition, cross through the focus. That's the definition of the focal point. Parallel lines that come in parallel to the principal axis, will cross through the focus. Parallel focus is the first line. Second line, focus to parallel. Anything that goes from the focus and hits the mirror is going to leave parallel. We're going to choose one that goes from the focus and our object, intersects both, and then hits parallel. Third line is center to center. If you hit tangent to the mirror, you're going to come straight back. So anywhere, if you start in the center of the hemisphere, when you hit the mirror, you're going to be perpendicular or normal to the surface of the mirror, and you're going to reflect straight back through the center. Parallel focus, focus parallel, center, center. Okay. Orange line. The orange line. Way over here. Here's the object. This arrow up is the object. It's important on your objects to have a direction so that you can see if the image is right side up or upside down, if it's inverted, if it's real, if it's virtual, all of those things. So here we go. We have a real object. It is to the left of the mirror, and you're going to move on. All right, so the orange line. Orange line goes in parallel, right? And then it comes down through the focus. All right, the focus is that hash mark right there. And I know that's the focus because it's half of my radius. So if my radius is here to the mirror, focus is half of that. All right, first line, orange line, parallel focus. Second line is the blue line. If I start at the object and go through the focus, I'm going to reflect back parallel. So the blue line, blue highlighted, is the second line, focus parallel. Any line that leaves the object goes through the focus goes off parallel. Third line is the yellow highlight, which is tough to see on this, center to center. It goes straight through the midpoint, hits the mirror, down, right there. Hits the mirror right there, and goes right back. All three of these lines intersect right there, which they all start at the top of this arrow, so they all finish at the top of that arrow. That is the image. Several things. That is a real image. You take and you put a projector screen right there, and real light lands on the projector screen, and you can see an image. This is real light. This is not behind the mirror. Behind the mirror is virtual light, and there's a virtual image. Out in space, if you could put a projector screen there and collect and have all the light land there and form an image, that is a real image by definition. We're going to use the construct. We're going to have solid lines be real light and dotted lines be virtual light. A couple other things. You know what? We'll come back to the equations. I just want you to see what P, Q, and F and these lines do in sequence. So we have an object. We have an object that's very far back compared to the focus. It's very far back from the center of the mirror. So the object is really far away. Now we're going to zoom in. We're going to put an object way up in here, okay? Up in here. And now, let's see what that happens. All right. We have increased the size of the mirror. The radius went to 8 centimeters. So the focus is 4 centimeters. Here we go. We have an 8 centimeter mirror. Focus is at 4 centimeters right here. 4 measured over to the mirror. Done. Okay. Up top, that's your object. Arrow up. 3 lines. Parallel focus, focus parallel, center, center. First line, orange line, goes parallel from the object to the mirror and then crosses down this way. That's it. Orange line, focus, or parallel, focus. Second line, blue line, focus, parallel. Blue line starts here, goes down to the corner of the mirror, and goes across parallel. Those two intersect. You've got the center line. Now the center is actually behind the object, because any light that starts up on this path comes up here and reflects right back down. Okay, you'll notice that yellow line and these red and blue do not intersect. They would make some kind of triangle out in here. Even if you're very accurate with your graph paper, this is going to happen. Even if you are very accurate with your graph paper, because a perfect sphere doesn't work. We need a parabola over here. But we draw these as spheres, and as long as everything's okay, it's not bad. In fact, I think right here, this dotted line, if I did the calculations later, it should have been back here, which is close to where the yellow line would have intersected the blue. All right, so small angles off make big adjustments on your drawing, okay? The 3 lines will intersect at a point because it's perfect. It always works. Where that point is going to be the tip of the image. That is also a real image, even though it's now behind the object. The object is inside, really close in. You got your breakfast spoon. First image, you were back here. All right, now you got your breakfast spoon and you got your nose right up here. Okay? Third image. Actually, before we get to the third image, can I just, real quick, these are arrows. In all the good old textbooks, the good old-fashioned textbooks, all of those, these would have been candles because they emit light. And we know they emit light in all directions, 4 pi radians, or, all the 4/3 pi radians, whatever. They emit light uniformly in all directions. This, when you stand right, there's light coming off of this. It's not glowing. It doesn't have to glow and be a glow stick. You stand in front of the bathroom, like your shoe is not glowing, but you can see your shoe because light from the room bounces around and scatters everywhere, and every possible angle of light. I'm not gonna say every possible angle exists, but that's where we're headed, right? Depending on the light source, right? All the angles are represented, and light scatters. So light comes off of your shoe going that way, that way, that way. Only the one coming to your eye is the only one you see that actually matters to you, right? Someone else standing over there on the other side, light scattering off your shoe that direction. That's how they see your shoe. Shoe is not glowing. Shoe is reflecting. Okay? So these objects, when I say light comes off the object, yes, light leaves the object. It goes here off the mirror and then down, that way, right? All right. Third image. Again, we have zoomed in, have a radius of 8 centimeters, focus of 4 centimeters. This time the object is all the way in at 2 centimeters. What's interesting is the object right here has crossed inside. There's the focus, there's the object. So spoon was at a distance, spoon was here, and now spoon is here. You have put the spoon on your nose. Where is your image? Let's find out. First line, orange line. Parallel goes in. Parallel light then reflects off the focus. Down. Right there. Reflects off the focus. Goes in parallel and reflects off the focus. That way. Blue light. Blue line. Focus parallel. Well, you're inside the focus. So you just want this direction as though it came from the focus to the mirror, to you, to the mirror, right? If it came from the focus to you, to the mirror, and then bounced back, that's what you're looking for. That's the blue light. So focus parallel. Third line, center, center. But orange, yellow, and blue are headed this way. Orange, yellow, and blue are real lines. They are rays. They are all moving away from the mirror like this because light emitted from the object or reflecting off the object hits, and now they're all three headed this way. And they are diverging over here. So how in the world is there an image? Is there an image? There is an image. It's just not over here. If light hits the mirror and reflects back this way in a straight line, the light appears as though it came from ... over here. If this orange light, first line, parallel through the focus, if it is headed this way, it appears ... as though it originated from up here. And the yellow line this way appears ... as though it originated from over here. When you take all these dotted lines, they cross right there, and you have a virtual, let me put this up here for a minute. Whoop, you can see it. You have a virtual image. A virtual image is not a real image. A virtual image is just like the mirror in the morning. That's a flat mirror. This is a curved mirror, but the same difference. The image is virtual. There is no light behind the mirror in the hallway or in the wall. There is no light there, but the image appears as though it originated from there. It's a virtual image. That's what the dotted lines are for. That's what they represent, and that's what we're going to go with. All right, last little thing. How in the world do we calculate this? Because if we don't trust the geometry, if we're not good at the geometry or the drawing, how in the world can we calculate this and back this up? And it's so simple. It's just so simple. Right here. Whoop, over here. 1 over P plus 1 over Q is 1 over F. Object distance, image distance, focal length. That's it. For this first mirror, what do you have? You've got object is 8 centimeters back because it's this far, 8 centimeters from the mirror. The focal length is 2 centimeters from the focus to the mirror. The radius is 4 centimeters, right? So 1 over P, which in this case is 8, plus 1 over Q, we don't know where the image is 1 over 2, 1 over the focal length. So it's half minus an eighth, and then you flip it, because that number is 1 over Q. So Q is 8/3, which is 2 2/3 centimeters. So when I start here at the mirror and I measure over to this image, hey, it's 2 2/3 centimeters, where it should be. Easy. Done. 1 over P plus 1 over Q is 1 over F. Second time. Now that we've moved, cool. Same formula, 1 over P, 1 over Q, 1 over F. This time, what do we have? We've moved the object to 6 centimeters with a focal length of 4 because we made the mirror bigger, right? So you've scooted in, and now the focus is right there in front of you. Basically, whenever you cross this center, before you were back here, behind the center. Now that you're crossed between the center and the focus, things look a little different because the image goes behind you. The equation still works the same. 1 over P, which is 6, plus 1 over Q is 1 over F. In this case, 1 over 1 over 4. So 4th minus the 6th, and then flip it. Q is 12 centimeters, which if you measure from here along the principal axis, that is 12 centimeters over right to there. Actually, I measured, since these didn't cross perfect, it's the dotted line back here. No big deal. 1 over P, 1 over Q, 1 over F. Same mirror, same formula, third time. Be careful here. 1 over P, 1 over Q, 1 over F. We have moved very far inside, and you are now at 2 centimeters. So you are only 2 centimeters from the mirror. From here to here is 2 centimeters. So 1 over 2 plus 1 over Q is 1 over F, and F is still 4 centimeters, just like last time. So 4th minus a half, then flip it. Q is negative 4. Why is it negative? Why is it negative? Negative signifies, negative tells you it's virtual. Dotted lines should be happening. Negative Q tells you it's a virtual image. It should be on the other side of the mirror. Well, other side of the mirror. It's a virtual image. Negative is virtual. Negative Q is virtual image. It's on the other side of the mirror. So all of those are concave mirrors. We'll do convex next time. We're going to practice drawing. All right. Check Canvas. There may be a small assignment or review of a different one, so you don't have to listen to me. Have a great day, everybody.